Okay, we're going to look at the review sheet, Chapter 4. So number 1 says 2 forces are applied to a 2-kilogram block on a frictionless horizontal surface as shown in the diagram. Okay. The acceleration of the block is, so first of all, you're going to say to yourself, I want to find the acceleration. And I know that F net is equal to ma. If I want to find the acceleration, a is equal to F net over m. When I look at my picture here, I see there's more than one force. So the net force would be the difference of these two. So once I find the difference in these two forces, now you notice how this one's going to the right and this one's going to the left. So this is where my sign convention is important. So you use whatever sign convention you want, but I would use my standard Cartesian sign convention that says up and to the right is positive. So now the net force, that would be 3 plus negative 8 over m, which is 2. So it would be negative 5 over 2, which would be negative 2.5 meters per second squared. Now, according to my sign convention, negative means to the left, positive is to the right, so that's why the answer is choice B, 2.5 meters per second to the left. So remember, force is a vector quantity. It has both magnitude and direction. Number 2, what force is necessary to give a 2-kilogram mass initially at rest an acceleration of 5 meters per second squared? So this is, again, just Newton's second law. So F is equal to ma, and it's equal to 2 times 5, which is 10. And a kilogram times a meter per second squared is a Newton. Number 3. This is, yes? Oh, I circled the wrong one. Oh, you know what? Because the one I printed, it's to the left. I circled the wrong answer. Sorry about that. The one that I printed here, the choices are different than the one that I gave you. Did you notice that? So that's why. The one that you have in your hand, the choices are in a different order. Okay. So it's to the left. All right. So a man weighing 800 newtons is standing in an elevator. If the elevator rises with an acceleration of 9.8 meters per second squared, the force exerted by the elevator on the man will be. Now, this is just like the lab we did on the elevator. So what you're going to do is you're going to, it's easiest to draw a free body diagram. Okay? So in the free body diagram, his weight acts down, which is 800 newtons. And it says the acceleration is 9.8. Now, if the elevator was not moving, I would have 800 newtons up because it would be equal and opposite, right? But the elevator's accelerating at 9.8. Well, 9.8 happens to be gravity. So in order to have an acceleration of 9.8 up, that 9.8 up is what his weight would be going down. So you would have another 800 newtons going up, because this would give me a net force of 0. If I had another 800 going up, that would give me an acceleration of 9.8 meters per second squared. So when it says the force exerted by the elevator on the man will be, and the answer is 1,600 newtons, because that's 800 plus 800 is 1,600. And that is choice C. Oh, I wrote B. Oh, I just circled the wrong answer for number 1. Okay. Trying to figure out what I was doing. All right, the next one is a graph. So even if we sometimes don't always think about things graphically, remember that graphs, and there's certain things in graphs that always mean something. So one of the things could be the slope. And when you think about the slope, especially in this case, it's a straight line, slope is equal to the change in y over the change in x, delta y over delta x. But let's read the question. It says the graph below represents the relationship between the forces applied to an object and the corresponding accelerations produced. What is the inertial mass of the object? So they want to find the mass. So I know that F is equal to ma. So m is equal to F divided by A. And this just looks like the same if I was doing a graph that slope is equal to delta y over delta x. So now I'm going to look at my graph, and what I do is I always pick the endpoint. So since this is a straight line that goes to the origin, I'll take this point and this point. So the slope will be delta y, which would be 1.5 minus 0, divided by delta x, which would be 3 minus 0, and that would end up being 0.5. 1.5 divided by 3 is 0.5, and that would be choice, whatever choice that is here. Okay, number 5, it says, if a baseball bat moving at a high velocity strikes a feather, if air resistance is neglected, compared to the force exerted by the bat on the feather, the force exerted by the feather on the bat, it's going to be the same. This is Newton's third law. So for every action, there's an equal and opposite reaction. Now this was some of the confusion on the quiz, which we'll go over in a little bit. Okay, number 6. If the mass of an object were doubled, its weight would be, so if you look at the equation, F of g is equal to mg, and this is, they do these types of questions on all standardized tests. So now they're saying if I double the mass, so now instead of m, I'm going to have 2m times g. So how is my weight going to be affected? These are directly proportional, so this would be, it would also be doubled. The graph below shows the weight of 3 objects on planet X as a function of their mass. The acceleration due to gravity. So now I want to find the acceleration due to gravity. Well, acceleration due to gravity is little g. So what equation do I know? I know F of g is equal to mg. So I have the mass, I have the weight. Remember, this is m. This is F of g, and I want to find the acceleration due to gravity g. So this is their relationship. So little g is equal to F of g over m. So it's equal to, so now I'm going to look at my graph again, and I'm going to pick some points, and I'm going to do the slope. And if I look at the graph, this is a straight line that goes through the origin. So I'm going to pick a point where it's kind of like easy to read. So to me, this is an easy point. So now I can do my endpoints here. So I'm going to do delta y over delta x, which is the same thing. So this is 300 minus 0. Again, here's 2 points to do the slope, divided by 50 minus 0. So 300 divided by 50 is equal to 6. Which is B. And again, the reason I got confused is the review sheet I gave you, I think the choices, the A, the B, the C, and the D are kind of different, right? Like they go A, B, C, D instead of A, B, C, D. All right, number 8. A 60-kilogram astronaut weighs 96 newtons on the surface of the moon. The acceleration due to gravity is, so this is again, F of g is mg. So g is equal to F of g over m, which is 96 newtons over 60 kilograms. Now let's remember our units. A newton is a kilogram meter per second squared. divided by a kilogram. So these cancel, and I end up with meters per second squared. Is that the correct unit for acceleration? It is. Number 9, a 70-kilogram astronaut has a weight of 560 newtons on the surface of alpha. What is the acceleration due to gravity? So it's the exact same thing. F of g is mg. G is equal to F of g over m. So it's equal to 560 newtons divided by 70, which comes out to be 8. Okay, now we're looking here, and it says the diagram below represents a block sliding down an incline. You always want to know which direction the object's moving, because that's your sign convention. So it's moving this way, and according to my sign convention, that's going to be positive. So it says which vector represents the frictional force. Frictional force always acts in the direction opposite of motion. So if it's moving down, the frictional force goes up. Okay, my worksheet's the one that I printed is wrong, so this isn't your number 11. I guess I printed the wrong version. So this is your number 11, right? The lawnmower? Okay. So number 11 says, a lawnmower is pushed with a constant force as shown in the diagram. As the angle between the lawnmower handle and the horizontal increases, the horizontal component. So the first thing I have to say to myself is, what's the horizontal component? So here's my force like this. So my components always have, this is where I start, this is where I end up. My components are perpendicular. So this is going to be Fy, this is Fx, and this is my angle theta. So because this is adjacent to the angle, Fx is equal to F cosine of theta. So now what I would do is, if you're not sure, just put in pretend numbers twice. It says as angle theta increases. So on your calculator, just pretend and just put in two things like 30 and 60. So if I do, that calculator doesn't work. If I do so first I'm going to say 30 cosine, and it comes out to be 0.866. So for 30 degrees, it's 0.866, and now if I do 60 cosine, it's 0.5. So as this angle increases from 30 to 60, the cosine of it decreases, which means that the force also decreases. Okay? This is not something you have to guess on. There's a simple way just to pick two angles, a smaller one and a larger one, put in the cosine of that angle, and figure it out. Okay, number 12 says, so this should be 11, this should be 12. It says a force of 100 newtons is applied to an object at an angle of 30 degrees from the horizontal. What is the magnitude of the vertical component? So here it is, and I can draw right on here. Here's Fx, and here's Fy. So if I want to calculate Fy, Fy is equal to F sine of theta, which is equal to 100 times sine of 30. So the sine of 30 is 0.5 times 100, ends up being 50. This is number 13. It says the handle on a lawnmower is held at 45 degrees. A force F of 28 newtons is applied to the handle. So that's this force here, as the roller pushes across the lawn. What is the magnitude of the force moving the roller forward? So forward is this way. That's forward. And that is the x component. Now for a 45-degree angle, sine and cosine of 45 is the same, but I'll still draw it anyway. This is fx, this is fy, so fx is equal to f cosine of 45. So it's equal to 28 times the cosine of 45, which comes out to be 19.8 newtons. And the answers for the other two, I think those are on your review sheet, aren't they? For 15 and 16? Okay.